Good evening, students. I'm your physics teacher Vikal, and today we are going to start reversible and irreversible process. Okay. So in last class we have seen refrigerator, okay. And one more before one last class we have seen heat engine also. Okay. So today we are going to see reversible and irreversible processes. जैसा कि नाम से आप लोग समझ सकते हैं, रिवर्सिबल मीन्स द प्रोसेस विच रिवर्स बैक and irreversible which cannot reverse. Okay, so let's understand these processes in detail. So first we will see irreversible process. First we will see general, like in our practical life, in our daily life, what happens. Okay, so if in practical life, if you will see, when you have a bottle of perfume, okay, so if you use that perfume or you sprinkle that perfume in room, then what happens? That perfume just spread over in whole room. Okay, so is it possible that that perfume which spread it in the whole room, can that perfume, can those drops of perfume, or you can say like tiny drops of perfume, can those drops revert back, or can those drops क्या वो drops वापस आ सकती हैं बॉटल में? Is it possible? नहीं ना? So in practical life, in daily life, most of the processes are irreversible, or we can say almost all the processes which takes place spontaneously, those processes are irreversible process. Like if we burn the paper, like हम लोग अगर पेपर को जला देंगे तो क्या हो जाएगा? It will become ash. Okay, so that ash cannot become paper again. So it is irreversible process. There are plenty of examples. Like घर में जैसे हम लोग पूजा करते हैं तो अगरबत्ती जलाते हैं, तो you can see that smell of that we can say अगरबत्ती, it spread over in whole house. Is it possible that whole smell can come in one corner of the room, like it will just collect in one corner of the room or come back to that agarbatti? Is it possible? No. Okay, so all these processes which occur in our daily life are irreversible process. Okay, so like in, अब हम लोग बात कर लेते हैं इन थर्मोडायनेमिक्स सिस्टम के टर्म में. ठीक है, वी हैव अ पिस्टन सिलेंडर अरेंजमेंट. अब क्या हुआ, इस सिलेंडर में कुछ गैस है, वी हैव सम गैस इन द सिलेंडर. So if we give some heat to this gas, then what happens? This gas will do some work on the piston. Okay, gas will do some work on the piston, and that piston will start to move. That piston will start to move. It will reach somewhere here. Okay, it will start to move. So what happens? That piston is doing work on the surrounding, on atmosphere. Here, atmospheric gases will be there. Okay, so if piston is moving in upward direction, that means piston is doing work on the atmosphere. Okay, so heat is used in work done by the gas. We can see heat is converted into work done by the gas. Is it possible that work done again can convert into heat? That same work done. I'm not saying that if you will do work on the gas, again it can reject heat to the system, sorry, to the surrounding. Okay, so initially we can say, initially its state was, like we can say pressure was P1, volume V1, temperature T1. And after expansion we can say its state become P2, V2, T2. So is it possible to bring back the system from P2V to T2 to P1, P1, T1 without 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 any effect, और बिना किसी like कोई भी इफेक्ट छोड़े हुए एटमॉस्फेयर पे, सराउंडिंग पे और सिस्टम पे, लाइक जैसा सिस्टम पहले था वैसा ही सेम सब कुछ लाना, इज इट पॉसिबल? नो, इट्स नॉट पॉसिबल. ओके, कुछ ना कुछ चेंजेस रह ही जाएंगे, देयर विल बी सम चेंजेस. If we will bring back system from P2V to T2 to P1 V1 T1 like this gas, from P2V to T2 to P1 V1 T1, it is not possible that जैसा भी सब कुछ पहले था वैसा का वैसा सेम आ जाए. Not possible. So in our daily life, like in our practical life, practically we can say all process which occurs spontaneously in nature are irreversible. जितने भी प्रोसेस हमारे नेचर में अकर होते हैं स्पॉन्टेनियसली, मतलब अपने आप, वो क्या है? इरिवर्सिबल होते हैं. उनको दोबारा से वी कैन नॉट रिवर्ट दोस प्रोसेस, like we cannot achieve that initial state of that process. So practically we can say all processes which occurs spontaneously in nature are irreversible. Like a cup of tea, a hot cup of tea. So spontaneously means अपने आप क्या होगा? What will happen? That hot cup of tea will become cold. But is it possible that cold cup of tea will become hot? No, it's not possible. It's not possible. Okay, so that is irreversibility. Okay, so irreversibility, there are mainly two causes of irreversibility. One is non-equilibrium state. Non-equilibrium state. मतलब if system is in non-equilibrium, like we can say free expansion का केस हमने देखा था. We have seen free expansion. What was free expansion? If gas is filled here, and here vacuum is there, and suddenly if we will remove this wall, then what happens? Gas will start to rush in this vacuum here. So what will happen? Here gas will be in non-equilibrium state. In this case, gas is in equilibrium state. Like we can say its pressure is P1, volume is V1, temperature is T1. But when we will remove this wall, so what will happen? Gas will expand freely, or we can say gas will expand against the vacuum. So and in this state, we can't define any state variable for this gas. That means gas is in non-equilibrium state. Okay, now if gas will fill this whole container, then is it possible that gas will again come to that same volume, will achieve that same volume, will revert back to the same pressure or same temperature? No, it's not possible. So non-equilibrium state is the one of the reason behind this irreversibility. Okay. Second is dissipative energy. Dissipative energy, which is because of due to friction, viscosity. So due to friction and viscosity, what happens? Heat will get dissipated, and that dissipative heat cannot be recovered. I'll give you one example. If you have a block, and you give some velocity to this block, like v velocity, and here some friction is there on the floor, then what will happen? After some time, this block will come to rest, velocity will become 0. So when velocity was there, its energy was what? What was the energy with this block? It was half mv square, kinetic energy. But here, what is the kinetic energy? Kinetic energy is 0. So where that energy vanished, that energy dissipated in form of heat because of friction. This floor will take that heat. So is it possible that floor will return back that heat energy to this block in form of kinetic energy, and that block will start to again move? Is it possible? No. Is it possible? No, it's not possible. So this dissipative energy due to friction and viscosity, it's also one of the reason behind this irreversibility. Okay, so most of the processes in our nature which occurs spontaneously are irreversible. Okay, I hope understood. चलो अब देखते हैं रिवर्सिबल प्रोसेस. Okay, so reversible process are ideal process. ये हम लोग पढ़ते हैं, ये हमारे किताबों में ही मिलते हैं ये प्रोसेस. These processes are not like possible practically. Okay, so ideal process. So what are reversible process? Reversible process are we can say quasi-static process. And as I told you, quasi-static process is what? Almost static. Quasi means almost. Static means at rest. So quasi-static process are almost at equilibrium. And these quasi-static process, we can say, takes place in so many stages or in so many steps. As I told you when we discussed about quasi-static process, I told you what? Like this is piston cylinder arrangement. Here some gas is filled here. So if you will drop a grain of rice here, then what will happen? That piston will move slightly. And then what will happen? Pressure of gas will increase, and gas will apply some force again on the piston. Piston will stop. Again, one more grain of rice you put here. Then what will happen? Again, piston will move slightly. And then gas will compress, and gas will again apply force opposite to that piston. So what will happen? That piston is moving, but it is moving in so many stages. So what is that process? That process is quasi-static process. So that process is almost reversible, almost at equilibrium. Okay, so one condition is process should be quasi-static, and another condition is frictionless process होना चाहिए. मतलब जो piston होना चाहिए वो frictionless होना चाहिए. Okay, so example, we can say example of the reversible process. Isothermal expansion. One more thing we have to add: frictionless isothermal expansion, frictionless isothermal compression, like that. Okay, so it will be the example of reversible process. Okay. Now one more thing. Why are we studying reversible process? Why is it important? Because as we have seen in last class that efficiency of heat engine is not 100% possible. Like 100% efficiency of the engine is not possible. Okay. Why? Because of second law of thermodynamics. Second law of thermodynamics puts restriction on 100% efficiency of heat engine. Okay, so heat engine की efficiency 100% नहीं हो सकती. Why? Because second law puts the restriction on the 100% efficiency. Okay, so now what can be the maximum efficiency of a heat engine? What can be maximum efficiency of a heat engine? Okay, so that's why what are we doing? We will make a cycle, an engine, which works on a reversible process. In reversible process, we know there will be like very small losses will be there. Like we are assuming frictionless, and we are assuming that process is quasi-static. Okay, so there will be very small losses in the reversible processes. Okay, so that's why we will make an ideal engine, and that engine is called as Carnot engine. So we can say father of thermodynamics, thermodynamics, Mr. Sadi Carnot. उन्होंने इस साइकिल को, कार्नोट साइकिल को डिस्कवर किया था, और कार्नोट साइकिल tell us that what can be the maximum efficiency of an heat engine. Okay, so understood what is the importance of reversible process. Reversible process क्यों जरूरी है? क्योंकि 100% efficiency तो नहीं हो सकती थर्मोडायनेमिक्स के सेकंड लॉ की वजह से, बट कुछ ना कुछ तो मैक्सिमम एफिशिएंसी होगी ना हीट इंजन की. So that maximum efficiency, how can we find? By making an engine, by making a cycle which works on reversible processes. Okay, so practically we have all the process irreversible, but we can get the limit that this will be the maximum efficiency. Our engine cannot go beyond this efficiency. Okay, so that maximum efficiency we can tell for a temperature limit, for a source and sink temperature limit. Okay, so I hope all of you understood what is irreversible and reversible process. Okay, so we'll just do one question which is based on reversible and irreversible process. So which of the following processes is reversible? So इन सारे प्रोसेस में हमको पता करना है कौन सा रिवर्सिबल है, कौन सा रिवर्सिबल प्रोसेस है. Okay, so first is, you can see, transfer of heat by conduction. So as we know, conduction is heat transfer, a process of heat transfer, we can say a way of heat transfer by contact. If two bodies are in contact, then what happens? Heat transfer from higher temperature body to lower temperature body. Okay, so this will not be reversible. This will not be reversible. Why? If two objects are in contact, we can say like this. So initially it has 80 degrees Celsius and it has, like say, 20 degrees Celsius. Then what happens? Heat transfers from this body to this body. Now what will happen? After some time, they both will have a common temperature, Tc. It can be like any temperature, like we can say it can be 50 degrees Celsius, 50 degrees Celsius, but it depends on the like their conductivity also. Like I'm just telling you, it can be 50 degrees Celsius. Okay, now is it possible that 50 degrees Celsius, this is 50 degrees Celsius, after some time what will happen? Both temperature will become equal and two bodies will be in thermal equilibrium. Now is it possible that this is happening what? Spontaneously, without any like effort. Heat is taking place, heat is transferring from 80 degrees Celsius to 20 degrees Celsius without any effort. Okay, so is it possible now this 50 degrees Celsius will lower its temperature and it will give heat to this 50 degrees Celsius, and this will become again 80 degrees Celsius? Is it possible? No. Is it not possible? Okay, so transfer of heat by conduction is not reversible. Whatever heat, this 80 degrees Celsius given 20 degrees Celsius, it cannot be retrieved back. Okay, so it is not reversible. Similarly, transfer of heat by radiation, it is also not reversible. Electrical heating of nichrome wire, this is also not reversible. Like we know nichrome wire, heating of nichrome wire, or we can say we can take an example of like bulb. In bulb, what is there? Tungsten wire, tungsten that is there, filament is there. So what happens? Electricity is supplied, current is supplied to this bulb. Because of that current, this gets heated. This gets heated. Q heat, it will reject some heat Q. So is it possible that same heat that nichrome wire will take, and again that heat can convert into current? No, that heat cannot convert that itself into current, that same heat. Okay, so it is not possible here. So electrical heating of nichrome wire is not a reversible process. So remaining is isothermal compression. Isothermal compression, and that isothermal compression should be frictionless and reverse. Frictionless isothermal compression can be reversible. Okay, understood? Frictionless and quasi-static. And frictionless and quasi-static, then it will be reversible process. These three are not reversible. These three are practical. Practical. Transfer of heat by conduction, transfer of radiation, transfer of heat by radiation, electrical heating of a nichrome wire. Okay, so these three will not be reversible, but this can be reversible if isothermal compression is frictionless. Okay, so